and nickel in the same slot, and this were placed in the same column as a fluorine, which means that he put here, like you can able to see the cobalt and nickel. He put below to calcium. How it is possible? The cobalt and nickel characteristic is different, property is different, and the hydrogen, fluorine and chlorine property is different. So because of that, the bromine which have a very different properties than this element. So here it failed. Cobalt and nickel cannot able to come in a group with a chlorine, fluorine, because the property are different, very different. Next point, the ion which resemble cobalt and nickel in a properties has been placed far away from this element, which means that the ion Fe is some property are correlate with that chlorine, fluorine and bromine. So he have to put that ion near to that chlorine, fluorine, but the ion put very far away from this cobalt and nickel. So because of the ion which resemble cobalt and nickel in a property has been placed far away from this element. I hope till here you understand. Mendeleev periodic table I will explain you in a next class. So you read it very well, and if you find any query then you can ask. Thank you. Good morning student. I hope you have done your first two chapters, student. You have prepared all the question answer, and there is no query, right? And you have done your exercise from your first two chapters. Now today I am going to explaining you the chapter number 5, the periodic table. Student, this chapter is very important for your exam point of view, 9th standard as well as 10th standard, and those who want to take the 11th 12th science, then this chapter also is very basic thing to learn a further detail about the periodic table in higher standard. So this basic thing if you cannot able to understand, then the further things regarding these points which are given in this chapter, that if you cannot able to understand properly, then you will not get that at that time, that particular point. So just pay attention whatever I am explaining and whatever you are learning in this chapter. So this is new thing that you are learning. As we know that student, we learn so many things about compound, about mixture, right? In 6, 7, 8 standard we learn about the numbers of compound, we learn about the numbers of mixture. When we learn that the compound like H2O, or we learn that like glucose and sugar plus water. So all this thing we learn, but this thing comes from the particular element like hydrogen, oxygen, carbon, nitrogen, everything are there. So we learn now from basic, that where this element come from and how it is arranged. So you know about the periodic table, you learn something about the periodic table, or you have seen so many places the periodic table. So from today we are starting this chapter, and we are learning that what is the periodic table and what are the property and what are the elements and where its place and why this place is given to particular element. Every single thing we will learn in this chapter. So we'll start. First, introduction. In a human instinct of classified, to put things of one kind in a one group and the another kind in a another group, which means that suppose there are 100 students in front of the teacher, but the teacher cannot able to recognize the everyone and everyone, what are the age, what are the class, which is not, she cannot able to recognize. So what a particular thing, first thing they can according to their age. Suppose some characteristics he choose, that teacher choose that okay, I classified all the students into their ages or into their class regarding to their classes. So see, teacher can arrange according to that this 10th standard student, 9th standard student, 8th standard student. So like this they arrange in a particular manner. So they classify the student, that 8th standard, 9th standard. Now the teacher can able to recognize the every single student in a group, that these students are 8th standard student, these students are 10th standard student. So that are human instinct to understand and to classify the things if the number of things are bigger in a amount. So same thing regarding element. Then in 18th century, the few elements, there are hardly 6 elements discovered in 18th century. But after end of the 18th century and beginning of the 19th century, more and more elements discovered. If we have a 6 element, then we can easily memorize and we can easily write down the property and the characteristic of the particular element. But if the number of elements are more, then how we can able to memorize all the property and the characteristic of the element? So we need to classify it. So in 19th century, more and more elements began to be discovered and their individual property and compound had begun to be studied. Soon the need arose for classify them so as to make their comparative study easier. So to make it easier, need to be classified. So for here it has given the reasons for the classification of element. So first reason, it helps in studying the element in an organized manner. Okay, we can manage the element that through that in particular groups. So through we can able to find out, okay, this groups is particular name is given, particular family's name is given, and that according to that property we can able to recognize the particular element. Okay, so the help to study the element in organized manner. Second, it help in a correlate the property of the element with the fundamental property of all state of matter, which means that it can help that suppose there are putting one group and they are making one group, suppose A, B and C, they make group like this A, B and C. So this A element, B element, C element put in a one single group. So suppose this property have a metal characteristic, this element also have a metal characteristic, this also have a metal characteristic, all of them have a metal characteristic. So we can able to find out, suppose they are putting in a one group and we can say that these groups are metal. So this is metal, which means this also metal. So through the one element we can able to find out, if we know about this element and the other element putting in same group, so we can able to find out the other element property also. So it will help to understand. So it's help to correlate the property of the element with the fundamental property of all states of matter. Okay, and all states of matter, which means that this metal, this is metal, and the another group, suppose non-metal, suppose D, E, F, this group is a non-metal group, right? So this is metal group and this one is a non-metal group. So we can able to see that the A can correlate with the D and make a substance, right? So this property, if we know the property of this group, if we know the property of this group, so we can make them and we can find out that how they are combined together and how they are making a one substance. So that thing we can able to find out through the periodic table, and it help in identity the relation of the one element with the another element, as I said before. So in the beginning, so because of this reason they start to classify. So in the beginning, first so many chemists attempt on the classification. So the attempt were made by a chemist to classify element on the basis of factor such as density. So first they make that this element density are near to each other, or density are just like similar. So they make a group according to the density. Then malleability, then ductility. So they chose a particular characteristic and according to that they make a groups, but they may be failed. So after that also to consider where the metal and non-metal. So then they found that some are metals and some are non-metals. So they divide into that, but none of this earlier classification prove satisfactory, which means that all this classification, they choose a particular property, all this classification could not fulfill for all the element. Why? Because here it is given, the number of elements falling in the particular group were so large, and that it did not serve the purpose of the generalization, which means that the number of elements are so many and the particular group were become so large. So non-metal, there are we know that there are 118 element in a periodic table, and from 118 element the maximum amount of the metals are there in an element. So it become big large group, and then that purpose to learn about the element and the characteristic which not serve. So that is the first reason. Second reason, some of the characteristic being considered varied under the different condition, which means that some characteristic are different, like some element behave as a metallic and some behave as a non-metal. Like here it is given, the certain elements show the metal as well as non-metal characteristic. Nowadays we know that there are metalloids, there are few metalloids are there which behave sometimes metals and sometimes they behave as a non-metal. So that characteristic is not fulfilled and in certain condition. So these are the reason that this metal, non-metal, density, malleability, ductility, this property is not considered for the classification of the element. Okay. So afterward, when this classification is going on, at that time one of the scientists, William Sprout, this William Sprout, he is the scientist who find out all the element atomic mass. So obviously a scientist were in a search of the characteristic of the element that would never change. So it will, which means that the scientist was discovered at that time, all the scientists were discovered at that time that we need to find out the one characteristic which never ever change. Like, okay, so at that time the William Sprout was who discovered the atomic mass of the element never differ, and that could therefore form a truly scientific basis for a satisfactory scheme of the classification, which means that when William Sprout, when discovered the atomic mass of all the element, he discovered the atomic mass. At that time this classification of the element become very easy, because of the element have now its own atomic mass. So through the atomic mass we can able to find, we can able to classify. So it become very easy to classify. So then the one of different now we will learn about the different chemists or scientists who try to classify periodic table. Okay, try to classify the element in a particular way. So first attempt, that is a Dobrynin, one of the scientists, J.W. Dobrynin, he attempted to classify element. So he German chemist observed that a certain element display a similar property and that they could be placed in a group of 3 elements each, and these groups of 3 elements each were called triads. Remember this, underline this, the triads. The group of 3 elements each are called triads, which have a similar properties and they could be placed in a group of 3 elements. Okay, so triads, I will explain you triads, which means that suppose here A, B and C, A element, B element and C element, they put in a one group and call is a triads. Triads. Why triads? Triad, which means that a 3, pair of 3. A triad, which means the pair of 3. Okay. So why only 3? Why not 4? So let's learn. The 3 element of the particular triad had a similar chemical property. So in fact, a Dobrynin was the first scientist to show the clear relationship between the properties of the element and its atomic mass. I hope you don't understand this, I know that, but I am explaining in very detail. First we'll see that what is the statement given by the Dobrynin about the triads. So, the atomic mass of the middle element of a triad was approximately equal to the arithmetic mean, which means average, of the atomic mass of the other two element of that triad. So, I am telling you what is the meaning of that. The meaning of that, the A atomic mass and C atomic mass. Suppose A, small a is atomic mass of the A and small c is the atomic mass of the C. So, the third element like B, that atomic mass is a mean, like A plus C divided by 2, whatever we are getting, that number is the atomic mass of the B. Okay, I repeat one more time. I am giving you example here, it is given in your textbook. See, the calcium atomic mass is 40. He put this Dobrynin put first the calcium, strontium and beryllium in a triad. Okay, so calcium atomic mass 40, strontium 88 and beryllium 137. So on basis of that, the 40 plus 37 divided by 2 is equal to 88.5, which is nearly to strontium atomic mass. So that is why he put a triads, the first element and last element atomic mass average is a middle element atomic mass, and all the property like calcium oxide, strontium oxide and the beryllium oxide have a same property, same characteristic. Calcium have a 2 valency, strontium have a 2 valency, beryllium have a 2 valency, and all of them are metal. So, these three properties similar plus this triad have this atomic mass also we can able to find out. So, by this way he make this triads. Okay. So, I am repeating all this thing, if you cannot able to understand, here it is given in your textbook. The following example we make the point clear. Take a 3 element calcium, strontium and beryllium. This element have a following similarities. All are metals. Each has a oxide that is alkaline in nature and each has a valency 2. Okay. So, as I told before here that calcium, strontium and beryllium, all of them have a plus 2. We are writing Ca plus 2, Ba plus 2, Sr plus 2, right. So, all three of them have a plus 2 valency, all three are metal and all the three oxide form, which means calcium oxide, strontium oxide and beryllium oxide have a same characteristic. So, the all oxide in alkali in nature, which means that all the three oxide are the alkaline in nature. Now, what is the alkaline? We learned that alkaline basic characteristic, all of them have a basic characteristic. So, the alkaline in nature. So, since this element have a similar chemical property, they were put together in a one group or to form a triad called Dobrynin triads. So, now you understand what is the statement given by, which is given here. The atomic mass of the middle element of the triad was approximately equal to the arithmetic mean of the atomic mass of the other two elements of that triad. Okay, hope you understand this. So, same thing is given here. The atomic mass of 40, strontium 88 and the beryllium 137. So, the average, as I explained, same thing, 88, which is nearly to same the atomic mass of the strontium 88. Another example also given here. Take a 3 element chlorine 35.5, bromine 80, iodine 127. Okay. So, this element also I am writing here. First what he took, a chlorine, bromine and iodine. So chlorine have a 35.5, iodine have a 80, bromine have a 80 and iodine 127. So the first and third element average 35.5 plus 127 divided by 2, the average is almost 81.25, which is nearly to this 80. And another thing, all three are non-metal, all three have a -1 valency, right? And all the react with water to form acid. All can react water to form acid, like HCl, HBr and HI, they form acid. This HCl, HBr and so their hydrides, we can say hydrides form, all of them hydride form are acid. Okay, so this characteristic are similar. So all the non-metal all react with water to form acids and all have a valency +1. So this mean of the atomic mass of chlorine here approximately. Okay, so but this theory was discarded, or this theory is not furtherly accepted. Why? The reason for the discarding the law of tride. First, a Dobrynin failed to arrange all the known element in the form of tride. He cannot able to arrange all of that element which were discovered at that time. Few element he can able to manage. Second, the law did not fully apply even within the same family. Like here, for example, the halogen, like a first 3A member of the halogen, fluorine, chlorine and bromine. So fluorine, chlorine and bromine, they are the member of the one family. We know that right now. The fluorine, chlorine, bromine and iodine are present in a one single group. So the fluorine, chlorine and bromine if we take, so the if we take out the average of the fluorine and bromine, then the 35.5 have to be there. But instead of 35.5, it comes a 49.5. So Dobrynin's scheme of the classification of the element was not very successful. So through it did contain important instinct and the principle, which means that if it is not successful, but somehow it gives some principle and instinct to classify it further. So on basis of that, one of the scientists, Newland's law of octave, he discovered another element. He discovered another classification, which is called Newland classification of octave. Octave, which means 8. So the John Newland, a scientist and a lover of music, arrange element in a ascending order of atomic mass. Ascending order, which means that atomic mass smaller to bigger, ascending order of atomic mass. And he found that every 8 element has property similar to the property of the first element. Like, what is the meaning of that? Meaning of that hydrogen, lithium, this is the increasing order of the atomic mass. So he put first, second, third, fourth, fifth, sixth and 7. Now after the 7, number 8 will come. So the 8 number characteristic, 8 number is a fluorine. So that fluorine characteristic is matched with the hydrogen. So he put that 8 number near to the below to the 1, which means that only he is telling. The property, the 8 element had a property similar to the property of the first element, which means that the first hydrogen, now after the oxygen, fluorine will come. So the fluorine he put below the hydrogen, which means that the fluorine characteristic is matched with the hydrogen. Then one more time increasing order, and after the sulfur, the next element he put to the first, so chlorine. So same way he put all the element. So just the 8 note of the musical octave like sa, re, ga, ma, pa, dha, ni. So these are the pa, dha, ni, sa. So octave. So after the ni, sa will come first. So this is the way do, re, mi, fa, sol, la, ti, do. So do will come here. This is Western music and Indian music. So according to that, he put the all the element like octaves, right? You learn, those who are learning music, they know the octaves, octave which means the sa, re, ga, ma, pa, dha, ni, sa. So he put that all the element like that. So according to the Newland law of octave, when elements are arranged by increasing atomic mass, the property of every 8 elements starting from any element are the repeating of the property of the starting element, which means that this property and this property, all the properties. Suppose I am start from here, beryllium. So the beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium. So magnesium property is similar to the beryllium property. Okay. So this is the way it is, he represent his classification. So now Newland. So the property of the every 8 starting up any element are the repeating of the property of the starting element. So I hope you understand this point, that suppose this all the element he put here, that same characteristics, same property are there. He told like this. So the Newland divide the element into horizontal row, like 7 horizontal row he put, each of so about the noble about. But the noble, at that time the inner gases were not known. At that time inner gases was not discovered. So inner gases is not there in this classification. So what are the merits? Merits, which means the advantages of the Newland merits. So this system work quite well for the lighter element, which means those do not have a higher atomic mass. For example, lithium, sodium and potassium were brought together. They have same characteristic. Nowadays also lithium, sodium and potassium are in same group. So this is somehow it is good. Second, it relate the property of the element to their atomic masses. So it relate all the atomic masses. Third, for the first time it was shown that there is a distinct property periodicity in the property of the element. So the first time he found this type of rows and the proper amount of the element present in a particular group. So he become very successful at that time. But after some time, so because of this octave rule, Newland was honored in 1887. The Royal Society presented the Davy Medal to the Newland in 1887 for his work of the classification of the element, because he does very well, he does very nicely all the element arrangement. So because of that he got a medal for that. Okay. Now the reason after some time is discarded. Why it is? Let's learn the reason for the discarding the law of octave. First, this classification did not work with the heavier element and those lying beyond calcium, which means that the heavier element, here it is, I told you the reason, that lighter element, because for the lighter element it is very nicely arranged, but for the heavy arrangement like a calcium and the other, he cannot arrange properly. So after the calcium, which means that atomic number after the calcium those elements have, they cannot able to fit in this classification, Newland classification. So this classification did not work with the heavier element, those lying beyond calcium. So as the more and more elements were discovered, they could not be fitted into Newland octave. Okay. So after the classification, other element discovered, so that element could not able to fit it in a Newland octave. Now Newland adjusts to two element, cobalt